Hello, this is going to be a little demo of problem 3, or a similar problem to problem 3 in your evaluation assignments. So this scenario is that an animal trainer recorded the number of rewards it took 8 puppies to learn a new behavior, shown below. And we're asked to find the minimum, maximum, and range, examine the scores to look for outliers, identify which score represents an outlier and what shape we predict, then to actually plot the data on a histogram, calculate mean, median, mode, sum of squares, variance, and standard deviation, and then considering the shape and outlier, determine whether mean or median would best represent the data and explain why. So here we have the 8 puppies and the number of rewards that it took. The first thing we do is find the minimum, maximum, and range. I'm writing my answers right here in the spreadsheet, but I am assuming that you would be writing these on a separate piece of paper. If you do have a pen and a touch screen, you too can do it right in the spreadsheet. So we'll start with A, minimum, maximum, and range. We'll just eyeball it to get these data. The minimum or the lowest number of treats was 2. Maximum number of treats I can see is 11, just eyeballing it. And the range is 11 minus 2 equals 11. B, examine the data to look for outliers. What score, if any, represents an outlier? So what shape do we predict? I think that this 11 looks pretty different from all of the other numbers. So I'm going to say that 11 is an outlier. That score, that number of treats was produced by 5. Maybe this group was younger than the others or had a traumatized life or something like that. Fear of humans. So, and I think I can see that this score is larger than the others. So I would predict that that tail is going to extend away from the cluster of data points or the cluster of treats between 2 and 6 and extend way to the right. And so this is going to be a right skewed distribution. Next, I'm going to actually draw the histogram using 10 bins. We do have a range of 9. That's enough for a simple frequency chart or a histogram. And so I'm just going to go right ahead on the axis. I'll make it short because the number in the sample is so small. And it says use at least 10 bins. So I'll go 2, 3, 4. This is referring to the number of treats that it took or the values. 5, 6, 7, 8, 9, 10, and 11. So here we do have the foundation for our frequencies. And this is the values for the number of treats. Over on the y-axis, on the y-axis, we'll put the frequencies. I'm just going to do it with x's. I'm not even going to write the numbers. So here we have 1 in the 2 column. Here we have 1 in the 6, 5, 3, 11, 4, 5. And if we are to trace the shape, we do see that we have a bit of rightward skew. And so we actually have the rightward skew that is predicted. Draw this gentle line over it to indicate that. Next, we calculate the mean, median, and mode. I'm going to go back to my draw menu then and erase all of this. So I'm going to get the calculations right there. And I'll do a little bit of zooming in so that you can see better. So we need mean, median, mode, sum of squares, variance, and standard deviation. On your piece of paper, you can continue downward, but in order that we can see everything on the screen, I'm going to begin writing up here just so that it can all be visible to you. So mean is the sum of all the scores divided by mean. And so we have to sum up all these scores. So we have 11, 15, 24 going down, 32, 38, and 40 is the total. And the sum of all those scores divided by n is 40 divided by 8 equals 5. So the mean equals 5. The median is the number that's in the middle when I rank these values. And so if I was to rank these values, I'm just going to write them out here. 2, 3, 4, 4, 5, 5, 4, 4, 5, 6, 11. 6, 11. And the numbers 1, 2, 3, 4, 1, 2, 3, 4. We have these two in the center, so we're going to say the median equals 4.5, the number right in the middle of those two digits in the center. Then the mode is the most commonly occurring number, and I can see that we have both 4 and 5. I would not say this is bimodal because they're right adjacent to each other. I would probably say, 4. Maybe we round up to 4.5. Typically, you don't do that with mode. Next, we've done mean, median, and mode. Next, sum of squares. I'm going to abbreviate SS. And I know that SS is the sum of all the square deviations. The deviations are x minus m. So I'm going to square all of those. So let's figure out the deviations. I'm going to go ahead and erase the ink on top of these numbers one more time. I'll just erase all of that going down. X minus m just means each score minus the mean. Here, I'll zoom in just a little bit so you can see a little better depending on your screen. We call that the deviation, or we can write it x minus m. X just means each individual score. So 2 minus, and the mean was 5, equals -3. 6 minus 5 equals 1. 5 minus 5 is 0. 3 minus 5 is -2. 11 minus 5 is 6. 4 minus 5 is -1. 5 minus 5 equals 0. Yeah, 4 minus 5 is -1. If we did it right, we should sum all of these up and get 0. Starting with the positive numbers, 6 plus, 1 is 7. Then the negative numbers, -3 minus 2 minus 1 minus 1 is -7. The sum of these equals 0. So even though the standard deviation conceptually is kind of like the average of all these deviations, we know that 0 divided by 8 is 0. So we have to go through and do this additional process of squaring the deviations. We can write it deviation squared, or we can write it x minus m squared, where we calculate each score. And so -3 squared is 9. 1 squared is 1. 0 squared is 0. The 2 squared is 4. 6 squared is 36. -1 squared is 1. See how we're nicely getting rid of all those negative numbers. 0 squared is 0. -1 squared is 1. And so now our sum of squares is the sum of all this. 36 and 4 is 40. 9 and 1 is 10. 52 looks like the answer. Sum of squares is 52. I'll drag my screen over so we can see. And zoom out just a little bit again. So sum of squares is 52. Then we know that when we're calculating the variance for an actual known data set, all we take is the sum of squares divided by n, which equals 52 divided by 8, which, let me get the calculator. I think that we'll just play on the safe side because we're also going to need to get a square root. So let's take 52 divided by 8. And I think that's my equal sign. 6.5, just as we would have guessed. 6, whoops, equals 6.5. And lastly, we get our standard deviation by taking the square root of the variance equals the square root of 6.5. And once again, let's get a calculator tool. We're not using Excel just yet because it's really good practice to get a little of this by hand work. And we get a 2.5495. We're probably done calculating with this, so we can just round it to 2.552 digits. If we were going to calculate by hand and use this answer for more calculations, we'd want to stay with 4 digits. For now, 2.55 equals 2.55. And the last question asks us, considering we have this one done now, we've done all of these. The last question, considering the shape and the outlier, would mean or median best represent the data? And so once again, when you're doing this work, you're going to put all of your answers down below. So this would be D, and please do this so that I can read your work easily. We know that when we have a skewed distribution, the tail of the distribution, the long tail, pulls the mean toward it. And so it's not a good idea to use the mean to represent this distribution. So we would say median would more accurately represent the data. We can see here that the mean is 5 and the median was like 4 or 4.5. We can see that this median is a better representative of where the data are falling than this mean. And so we can see that that tail is pulling on that mean just a little bit. We would say median is most representative. Because the tail of a skewed distribution distorts the mean. Just write M for mean, which is how we're using it here. A couple of things you'll see in your book. In your book, instead of writing this word variance, you're going to see SD squared. And another way of writing mean that you might have if you have a math background is X bar. Either way is okay. We're going to use M in here, and we're going to write out variance because it's just helpful to students who are new to these terms.